Perfect. Good job, Jaden. All right, who else haven't I talked to in a while? Like Richard. 45 degrees. What'd you get for your sine, cosine, and tan value there? Mm-hmm. Mm-hmm. Good. And then lastly, hey, Troy. 60 degrees. Yep. These are numbers that we use a ton coming up in section 1.4, so I kind of wanted to bring them to your attention now. This chart is also going to come up on a little quiz a little later on in the week. So it's my hope that you can fill out this chart, from memory, which most of you, it sounds like you're doing a pretty good job of. All right, just general question. It could be in math or outside of math, doesn't matter. When you put the prefix co in front of a word, what does that mean? What does that mean to you? You could think of another word that begins with co and talk about it that way if you'd like. In general, what does co mean? Hey, Shayla, did you put anything down for that? Two. Okay. What do you think, Joey? Together? Yeah. And what were you going to say, Madison? With or together. Yeah, that's what I think of. I think with, together, two things put together. I think of all of that. I'm with you guys on that. So good. Okay. In general, the topic for today's lesson is to discover cofunctions. What we're getting into in section 1.3, because this is the first part of 1.3, the topic is identities. And you've actually already done 6 of them. You did the identities for sine, cosine, tangent, cosecant, secant, and cotangent. Those were called your reciprocal identities. So you've done those. The next batch of identities are called cofunctions. And cofunctions are very interesting because you're going to use this chart in just a minute, or you could use your calculator in a minute. Cofunctions are actually particularly interesting when we analyze them within the context of complementary angles. So cofunctions outside of complementary angles, not really as interesting. But let's just talk about complementary angles for starters. Complementary angles, do you remember that term maybe from your geometry class? There are 2 angles whose sum is equal to, do you remember, Adam? 90, yes. Supplementary is 180. Complementary is 90 degrees. So you can pick like 30 plus 60. A 30-degree angle and a 60-degree angle will be complementary. They add up to 90. Or you could do, I don't know, like 40 and 50. 40 degrees and 50 degrees will give you 90 degrees. And we also have radians, right? You could pick like pi over 4 and pi over 4. If you put pi over 4 together with pi over 4, you get pi over 2, which is the radian equivalent of 90 degrees. And that was just to name a couple of examples. Really, any 2 angles that add up to 90 degrees or pi over 2 radians are going to fit in today's lesson quite nicely. Now the definition of the term cofunctions. To find the cofunction, of a trig function, you simply identify the root word attached to the prefix, co. That cofunction and the original function actually come together to make cofunctions. So here's what I mean by that. If you want to know the cofunction for sine, the cofunction of sine is cosine. If you want to know the cofunction for cotangent, that's just tangent. And we have one other. Anybody care to guess what it was? Think back to like what you did on your homework last night. Secant and cosecant. Yeah, very good. And you probably, maybe even a little bit curious about, like, why is there co in front of these things? You know, what's the relationship there? And that's what we're talking about today. What is the relationship between these trig functions that have just the function and then the prefix co in front of them? There has to be a relationship between them. What is it? And that's what we're talking about today. You're actually going to play around with it a little bit. You have an activity to do with the calculator, or you could use the chart, honestly, that we filled in at the beginning of the lesson today. It says use the chart, or, like I said, your calculator will verify this also, to help you answer the following questions. Now, we'll do the first couple together. Question number 1. 30 degrees and 60 degrees, when combined, are known as what type of angle? Pair. What type of angles? When you put 30 and 60, they are complementary, yes. So now you evaluate the following. You could look at your chart. And now we took the 30-degree angle and the 60-degree angle, and I had you find the sine of the 30, but the cosine of the 60. So you look at your chart, or throw it in your calculator, whatever you want to do. The y-coordinate at 30 versus the cosine, or the x-coordinate at 60. What do you notice? Yes, they're both what? 1/2. And Joey, you just answered my question for number 3. What do you notice about your answers to number 2, part A and B? They were the same. Okay. Now, you get 2 more batches of this. So 4, 5, 6, 7, 8, 9. I want you to go ahead and take a minute to just finish those up. Question number 4. You might have noticed, again, they added up to 90, so they were complementary angles. I'm not sure I even screen captured the next part. No, I didn't. Question number 5. Part A, you got the square root of 3 over 2. And B, you get square root of 3 over 2. However, for 6, when you look at part A and part B, what do you notice? They are the same, right? Part 7, again, 45 and 45, when you add them up, they make 90, so they're complementary. For 8A, it's the square root of 2 over 2, and B is the square root of 2 over 2. And what do you know about your answers? They are equal. Question number 10, the most important question in the whole activity. It has you summarizing today's lesson. If you can figure out the answer to number 10, you've essentially taught yourself today's batch of identities. And the question asks us, based on your observations above, what can you say about cofunctions for complementary angles? Cofunctions of complementary angles are equal. That's it. Okay. I want you to grab your calculator real quick. Notice I picked 30 and 60, 60 and 30, 45 and 45. We're going to do a couple more just on the calculator, just to make sure you understand it. Can you do me a favor and make sure you're in degree mode, first of all, because we haven't done this in a while. You press mode. It's right next to your shift key or your second key. Did you get it? Okay. Degree should be darkened. Scroll down, press degree, hit enter, and then make sure that's dark. Okay. You can go back to your home screen. Okay, so Jaden. I don't know why I'm picking on you today. I just realized I picked on you again. Sorry. Can you just name for me 2 numbers, 2 angles that would be complementary? Pick any 2 numbers you want. We did 60 and 30. We did 30 and 60. We did 45 and 45. I went like any 2 numbers. Yeah, sure. 50 and 40. Sounds great. 50 plus 40 would give us 90 degrees, right? Well, as it turns out, if I do the sine of 50 and hit enter, and now you hit the cosine of 40 and hit enter, what do you notice? They're the same. You could also reverse it. You know, I had you just press right now for this. I'm recording this lesson, so for the sakes of the people watching at home, if you do the sine of 50 versus the cosine of 40, here's what your classmates came up with. They saw they got the same decimal, right? Adam, Jay, can you pick another pair of numbers that add to 90? Ooh, 85 and 5. Okay, so if we did the cosine of 85, and stacked it up against the sine of 5, what do you think is going to happen? Madison. The decimal would be different, but they would still, those two values would be the same. You follow? Okay, cool. So I can elaborate. Like, the cosine of 85 was the same as the sine of 5. But if you did the sine of 85, you would get a different decimal, because that's a different y coordinate for that angle. So if you did the sine of 5, you'll see you get a different decimal. I meant cosine of 5, sorry. Brain-mouth disconnect. Cosine of 5 is still the same as the sine of 85. So you get a different decimal, but those values for sine and cosine are the same. Essentially, what I'm trying to teach you today is that cofunctions of complementary angles are always going to produce the same value. That's it. Okay? And you can even think back to it. It makes sense if you think about it within the context of the unit circle. Did you ever notice for like the 30 and the 60, the coordinates are the same, they just reverse? And then, you know, if you go into quadrant 2 and you think about 120 versus 150, they're the same coordinates, just reversed. That's because of the cofunction identity. You know, you can think of it that way too. All right. So let's make it official. Let's put it on paper. This is your cofunctions table. Something I ask you to bear in mind, the notation on this table is a little strange. Give you that. But what I want you to think about is this. See this 90 minus theta business? When they talk about 90 minus theta, what that means is the complement of theta. That's what that means. I'll show you what I mean in just a second. So what they're saying here is that the sine of 90 minus theta is actually the exact same thing as the cosine of theta. So notice I have cofunctions here, sine and cosine. And then, furthermore, if I look at the angles, see I have 90 minus theta. Bring this down. And the other green thing that's highlighted there is theta. Well, if I put those two things together, if I simplify this expression, essentially I have 90 minus theta plus theta. The thetas go away, and you get 90. So all they're saying here is that these numbers need to add up to 90. Those two numbers there are your complementary angles. So this one might be 30, this one might be 60, this one might be 5, this one might be 85, this one might be, Jaden picked what, like 40 and 50. Those angles there are complementary. Going across the table, if we're looking at cosine of 90 minus theta, that's the same as the sine of theta. So again, we just took the co off, and we have complementary angles. The tangent of 90 minus theta, that's the same as the cotangent of theta. Remember, don't write it unless you understand it. So essentially we have our cofunctions and then complementary angles right next to each other. We're studying today how they're the same. And then the cotangent of 90 minus theta is going to be equal to the tangent of theta. The secant of 90 minus theta is equal to the cosecant of theta. And lastly, the cosecant of 90 minus theta is the same as the secant of theta. So now we're ready to do a couple problems. Questions about this? All right. Try to figure out which one I want to do first. We'll go with part 1 here. All right. So in example 1, it says use the relationship between the cofunctions. Notice the directions. This time around, I want you to use the relationship between the cofunctions to find the indicated trigonometric value. Let me be very, very honest with you. I was very picky. Did you look at your assignment sheet for tonight? It's like a mishmash of problems, and then I picked part A from this one and part B from this one, because I picked a very particular set of problems, and I want them done in a very particular way. The way that we're executing in class today is the way I want you to go through and do your homework problems tonight. So for instance, do you see part A wants you to find the sine of 30 degrees? You already know one way how to do that. It's the y-coordinate at 30 degrees. But that's not what I need to teach you about. I need to teach you how to use identities to find another way to get the sine of 30 degrees. So that's what I'm showing you today. Okay, the sine of 30 degrees, if you think about today's lesson, is actually equal to one of these things given here. So if you look, we're given some information. We're given that the sine of 60, which is something that we know, is equal to the square root of 3 over 2. And then we're also given that the cosine of 60 is equal to a half. What I want you to think about is the sine of 30 is equal to one of these two things. I highlighted something in green, and I highlighted something in yellow. Can anybody tell me another way of thinking based on today's cofunction idea what the sine of 30 is equal to? Adam. It is equal to the cosine of 60, yeah. Based on the activity that you did at the beginning of the lesson, the sine of 30 is actually equal to the cosine of 60. And then they give you the cosine of 60 there. The cosine of 60 is a half. So notice you have to copy the problem, show a middle step. In other words, tell me which one of the given pieces of information, and it says it all on the assignment sheet. Give me the missing piece of information, or the given piece of information, rather, that your expression is equal to, and then use that to find the value. Let's do it again. Part B. The cosine of 30, based on today's lesson, is actually equal to which trig function up there? Good, Richard? Yep. The sine of 60. Very good, Richard. And that is now equal to the square root of 3 over 2. So that's how you could use cofunctions to evaluate some trigonometric functions. These get a little bit trickier. It always does as you work down the page for the most part. So now we have cosecant of theta is equal to 3. And then we have the secant of theta is equal to 3 root 2 over 4. I think I'm going to start a little bit more basic. I'm going to start with C and D before we jump too far into the problem. Okay, part C. Secant of 90 minus theta. The secant of 90 minus theta. If you go back to your cofunctions chart, again, we're taking a look at part C here. We're asked to find the secant of 90 minus theta. You go back to your cofunctions chart, the secant of 90 minus theta is actually equal to the cosecant of theta. Do you see that? So I can use that identity to help me figure out this problem. The secant of 90 minus theta, step 1 is to write what it's equivalent to. The secant of 90 minus theta is actually equal to the cosecant of theta. And they actually gave us the cosecant of theta in this problem. Cosecant of theta is 3. So the answer to that problem is 3. For part D, same thing. I look up on my chart, cosecant of 90 minus theta. I know that that is equal to the secant of theta. And based on what they give you in the problem, your answer is 3 square roots of 2 over 4. I held off on A and B because they're not, the relationship between part A and the given isn't a cofunction identity, is it? What I see is here, I have to find sine, and I have to decide, is it related to cosecant or secant? And using cofunctions doesn't get me there, because the cofunction for sine is cosine. So we have to use the identity we talked about yesterday, the reciprocal identity. So I have a question for you. The sine of theta is the flip of which one of these two things? Is sine of theta the reciprocal of cosecant? Or is it the reciprocal of secant? Do you remember? Adam. Cosecant. Yes, very good. So all I have to do is flip my cosecant value. So cosecant is 3 over 1. I know that the sine of theta is, what I'm trying to say, is the reciprocal of cosecant. And that's the symbolic language for the reciprocal of cosecant. You do 1 over cosecant. So if I need to just flip 3 over 1 to get my answer, it's just going to be 1 over 3. Also thinking back to the packet that we just went over at the beginning of class today, we're now asked to find the cosine of theta. Now the cosine of theta is actually a reciprocal function for one of the given pieces of information. And we already used cosecant. Adam, do you know the reciprocal function for cosine? It'd be secant. Yeah, very good. So I can go ahead and just flip secant to get my answer. However, flipping secant now gives me 4 over 3 root 2. And what's wrong with that? Yeah, you can't have a radical in the denominator. Very good. So we do have to rationalize. You end up getting 4 times the square root of 2 on top. And then 3 times the square root of 4, which is 3 times 2 or 6. And then you could reduce 4 and 6, right? We got 2 square roots of 2 over 3. Okay. So that's our lesson. We actually ended up using both identities today. We used cofunctions and our reciprocal identities. To close up today's lesson, I do want to point out your bookwork for tonight. So let's talk about that.